Welcome to PyTorch Basics for Machine Learning. This course is the first part in a two-part course that will teach you the fundamentals of PyTorch. Welcome to PyTorch Basics for Machine Learning. This course is the first part in a two-part course that will teach you the fundamentals of PyTorch. In this course, you will use PyTorch to implement classic machine learning algorithms, seeing how PyTorch creates and optimizes models. In Module 1, we'll discuss one-dimensional tensors, two-dimensional tensors, derivatives in PyTorch, and data sets. In Module 2, we'll discuss linear regression prediction, linear regression training, loss, gradient descent, and cost. Finally, we'll discuss training in PyTorch. In Module 3, we'll discuss stochastic gradient descent, mini-batch gradient descent, optimization in PyTorch, training and validation, and finally, early stopping. In Module 4, we'll discuss multiple linear regression prediction, multiple linear regression training, linear regression with multiple output prediction, and linear regression with multiple output training. In Module 5, we'll discuss linear classifiers, logistic regression prediction, the Bernoulli distribution, and logistic regression training, mean squared error, and cross entropy loss. Finally, you'll test your skills in an independent project.
In this section, you will learn about tensors and how they are the building blocks of neural networks in PyTorch. In this video, we will review tensors in one dimension and two dimensions, derivatives, the dataset class. In the simplest of terms, a neural network is a mathematical function. It takes in one or more multiple inputs, processes it, and produces one or more outputs. The following image is used to represent a neural network. In PyTorch, neural networks are composed of PyTorch tensors. A PyTorch tensor is a data structure that is a generalization for numbers and n-dimensional arrays in Python. For the neural network, the input x is to be a tensor. The output y will be a tensor. The network will be comprised of a set of parameters which are also tensors. For producing one or more outputs, the neural network will need to process its input. For processing, the neural network will apply a series of tensor operations on the input it receives. Many of these tensor operations are generalizations of familiar mathematical operations like multiplication and addition. In this course, we will focus on tensor operations that are essentially vector and matrix operations. For the rest of this course, you will convert your data into PyTorch tensors and will then use that as input into neural networks. For example, if we want to use a database as an input for a neural network, we could do so in the following manner. In this example, each row of the database can be treated as a PyTorch tensor, and we input each of these tensors into a neural network. Thus, we see that a tensor is simply just a vector or a rectangular array consisting of numbers. Let's take a look at another example in which we convert images to rectangular tensors. In this example, we convert each image to PyTorch tensors for using the images as inputs to the neural network. Images in Python are usually represented as 2D arrays and 3D arrays. Thus, in this case, each tensor of the input is simply a matrix or rectangular array. We also see that the neural network takes the input image, which was transformed to a PyTorch tensors, and classifies it as 0. Further, it's extremely easy to convert PyTorch tensors to NumPy arrays, and vice versa. This gives PyTorch the ability to work within the Python ecosystem. We can also easily integrate PyTorch with GPU. This is an important factor for training neural networks. Parameters in neural networks are a kind of tensor that allows you to calculate gradients or derivatives. Gradients and derivatives will allow you to train the neural network. We will use parameters for our neural networks in PyTorch by setting the value of the requires grad parameter equal to true. We will also review the dataset class, as using this class makes it much easier to work with large datasets in PyTorch.